Okay, so in the previous video we had been looking at the C3. Let's just bring that up here for one moment, and this is from Hal Varian's paper, and he had developed a C3 and provided some code, so we've used that code again, and I had explained in the previous video the basis of how the C3 worked. And in the case here of HMDA data, we could look at the outcomes in terms of mortgage approval or otherwise. So yes would imply denied, and no would imply that the mortgage approval had been successful. The vast bulk of individuals, it would appear, had successfully applied and obtained their mortgage. We had explained this side of the C3, it just remained to explain this side. So if the credit score was not less than or equal to 3, that would imply alternatively it would be greater than 3, so it would be 4, 5 or 6. If the individual had a public record of a bad debt, we can see here it affects the numbers quite substantially. There's less than a 50%, it would appear less than a 50% chance. If the individual didn't have a public record but had a higher credit score of 456 and the loan to value ratio was in excess of 95.3%, and we gave some discussion previously in relation to the loan to value ratio, we can see chances of obtaining mortgage, of being denied a mortgage, yes, denied, would be very high, close to 70% here, I would imagine. If the loan to value ratio is less than 95, but the debt service to income ratio was in excess of 41, it appears to be about 50-50. And then if the debt service to income ratio was less than 41% and the individual was African American, chances of mortgage being denied just over 20%, but if otherwise no, in other words the rest of the population, less than 10% chance of the mortgage being denied. So it's this discrepancy here that is being captured in the Manel et al. 1996 paper. The central thrust of the central research question related to race, and they found evidence to support the hypothesis that being African American meant that your chances of obtaining a mortgage were quite low. When we look at the C3 here, when we look at the status here, the racial status of an individual, it seems to be less center stage, and other factors seem to be dominant in and account for more of what's happening than purely race. It would appear here that race is more peripheral and less center stage, but that might also be accounted for by virtue of the numbers involved. And if we go back into our EDA analysis for one quick moment, come back to, we had a summary of the HDMA data. Let's just run that for a moment. And if we look at here the number of African Americans, there were only 339 out of the full sample of the 2,381. Because their numbers are a bit reduced, perhaps that's why in the C3 they're not as center stage. So we have to be careful here not to exaggerate or under play a little bit how significant race is, just from the optics of the C3. Okay, so let's, if we decided to run the C3 again, just include a much smaller set of predictors if we use a smaller data set. So let's just take this again, and we can copy and paste underneath. And if we change this to just two variables, DMI, and also include it in black. Okay, so paste again, and instead of having a full stop, we can do DMI, and I should have put plus black to denote African American or non-white perhaps, and change the small fit and run, or this reduced C3. When we generate this C3, we can see we're not denied mortgage insurance, so no. A small number were denied mortgage insurance, and overwhelmingly they were denied mortgages. But those who were approved for mortgage insurance, those who are non-black, so non-black here, this is the 2010, and then the balance was 322. And we can see if there's just these two explanatory variables, then we can see that different discrepancy between both populations or subsamples in the population is relatively stark. It's not insignificant. And again, does it warrant, does it license strong commentary or robust commentary to say that discrimination is prominent in mortgage lending decisions, mortgage approval decisions? Well, that's something that's I don't think has ever been fully resolved in the literature. Again, we're principally interested in looking at these technologies, and I'm following pretty much in line here with Halvarian R scripts, and we are going to investigate a little bit more thoroughly the C3. So again, we're going to run the C3 without this time any graphs. So we have all, as before, all fit. Again, that's the same C3 analysis as we have before. Now we're going to predict using that model. So this, if you like, has generated a C3 model that we can use to predict, all predict. And then we can do a table that compares the actual true deny to the predicted deny, right? So we can compare the fit of the model against the actual. Let's do that, and then create all and CONF a confusion matrix, I suppose. And then we can take a look at that confusion matrix. And what we observe using the C3, the predicted are the values below. So when we have no and no appearing together, that denotes that the mortgage was approved. So the model predicted this, it was also true. The model predicted the mortgage was approved, but in reality it was denied, yes, denied. And here the model predicted that the mortgage was denied, but actually it was approved. And here the model predicted yes, that the mortgage was denied, and actually was denied. So we can see here the amount of error actually is in these two cells of the 60 and 168. If we were to estimate the error here, we could take the 2, 1, so row 2, column 1, this value, row 2, column 1, and take this value, row 1, column 2, so the 60, and if we add both of those together, all error is equal to 228. So the sum of these two indicates or flags the level of error. Maybe to understand a little bit what all predict represents, we can run that and we can see the output. So that this is the given the each row in the data sets, the all data set, we can make predictions using the predictors, and that's the output. This is the actual mortgage approved, denied, and then the errors then serve to tell us how much errors in the model. So out of the 2,380 in the all 2,380, we have errors here of 228, which is not awful. It's a little bit, about 10% or so error that we're getting, a little bit less than 10%. Now Hal in his paper explains that if we exclude from the C trees the black variable, right, the race variable black shows up far down the tree. It seems to be relatively unimportant. But he also says if we exclude this variable and have a no black predictor, so in this instance, if we run the same, if we create a data set that excludes all, so if we open up in the Rstudio viewer, the 12th column here is black. If we exclude that from our data set and refer to that data set as no black, and then run the deny using the C tree, try to predict deny in the no black data set, and let's run and let's do a prediction. And then if we compare the all predictors, so if we then use the model here, when we ran that, we had predictions using all the data. And when we run, if we were to do the same with the no black fit, so if I just put in here no black dot fit dot fit, right, and if we run that, also we get we should get predictions, or no black predict, PRED. If I run that, we also get output. When we compare the model, the C tree model with no black predict against the all predict, and we run this script that compares both. So when we try to verify all equal, all predict to no black predict, what we find is it's true. All are equal. Again, we can use the help menu here to understand what all equal reveals. So if we run that, we can see in the help menu, we can perform a test to see are two objects equal to each other. So basically the upshot here is by excluding the 12th column, the column that represents or reveals if the applicant is black or not black, in terms of the model predictions, by excluding that particular column, our predictions are unaltered or unchanged. And again, that may signal that this is not such an important variable. I think that would run counter to the intuition provided by Manal et al. 1996, and I think the whole focus of the Federal Reserve of Boston's research agenda in that period was to reveal the extent to which discrimination occurred along racial lines. So again, sometimes you have to be careful how you use these trees. I like the C tree. I think it's a good way to visually understand what's going on. But also perhaps maybe when we're using these type of technologies and techniques, it makes sense to also introduce into the analysis more than just one particular technique. So we will proceed in the next video to look at random forest and logistic models just to compare our results here.